Click Tool School Generator. Click FPGA Features and Design. We found clocking wizard is on selected status. So we need to first create an IP project. Use the default name and file directory. Select the corresponding hardware model. Select Verilog in the Generation tab. Apply and OK. Then we can double-click Clocking Wizard. Frequency synthesis refers to this PLL that can be used to double or divide frequency. Phase alignment refers to the new clock will be aligned with the input clock. Dynamic phase shift refers to phases of new clocks that can change after clocks are generated. It will generate a variable called PSEN. We can change the phase by repeatedly enabling this variable. Data optimization mode and input data unit leave the default. Fill in the input clock frequency in the input clock information section. Here, our input clock is 50 MHz. Other options leave the default. Click Next. We aim to generate two clocks. The first one is 50 MHz and sets the phase shift to 90 degrees. The second one is 100 MHz. Normally, we use the default duty cycle, namely 50%. BUFG refers to that new clocks will use the global clock tree. Click Next. Here, we unselect Reset and Lock the signals. Clock feedback source leaves the default. Click Next. The wizard shows the details here. Click Next. We can change the input and output clock names. Here we leave the default here. Click Next, which shows files that will be created. Click Generate to generate these two clocks. It will take a while to complete it. Close the Core Generator window and right-click the Verilog project. Select End Source to end the file that the suffix is .xco. Select this PLL module and expand the design utilities. You can find a template that instantiates this PLL. Select and right-click this project. Click New Source and find Verilog test fixture. Define its name and save directory. Define the input clock period. Run the simulation. We can find the clock output 1 is 50 MHz with 90 degrees phase. Clock output 2 is 100 MHz. That's all for today's video.